Welcome to another math problem of the week. Integers, perfect square. Let's talk about it. For this question, A, B, C are integers such that the sum of the reciprocal equals to 0. You're asked to find one possible value of A squared plus B squared plus C squared. And the options are A, 2022, B, 2025, C, 2205, and D, 2209. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
I received many answers say that the answer is equals to B, 2025, simply because they can easily find A, B, and C that satisfy the first equation, and it can be written as A squared plus B squared plus C squared. And the answer is let A equals to B equals to 30 and C equals to negative 15. Now let's check. 1 over 30 plus 1 over 30 plus 1 over negative 15. Of course, this will be equal to 0. And 30 squared plus 30 squared plus negative 15 squared, that is equals to 900 plus 900 plus 225. After a bit of calculation, it is 2025. Now, of course, this is one possible value of A squared plus B squared plus C squared. When 1 over A plus 1 over B plus 1 over C equals to 0, what is so special about A squared plus B squared plus C squared? We also want to know why other options are not possible. From here, 1 over A plus 1 over B plus 1 over C equals to 0. This implies that none of the A, B, C equals to 0. Then we can multiply each of the terms by A, B, and C. And we'll have AB plus BC plus CA equals to 0. Next, A plus B plus C squared will be equals to A squared plus B squared plus C squared plus 2 of AB, BC, and CA. And since this is equal to 0, so it will mean that A squared plus B squared plus C squared is a perfect square. And since 2025 is actually equals to 45 squared, so this is one of the possible value that we are talking about. And easy we can find some suitable A, B, and C. But we also want to know why the other options are not possible. Let's look at the option A. 2022 is not a perfect square. 2205 is not a perfect square. So it cannot be a possible value of A squared plus B squared plus C squared. However, the option D, 2209 is equals to 47 squared, is a perfect square. But in this case, it's not a possible number for A squared plus B squared plus C squared. Why? Now note that the condition that we have here is if 1 over A plus 1 over B plus 1 over C equals to 0, then it implies that A squared plus B squared plus C squared is a perfect square. But it doesn't mean that it can be any perfect square. Let me erase this to save some space. So from what we have just now, A squared plus B squared plus C squared is actually equal to the square of sum of ABC. And 2209 is equal to 47 squared. Now we want to know whether it is possible. From 1 over A plus 1 over B plus 1 over C equals to 0, there must be 2 positive and 1 negative, or 1 positive, 2 negative. Without loss of generality, I'll let A be the greatest, and both of them positive, and C will be the smallest, and it is a negative. So C is equal to negative of 1 over A plus 1 over B, and that is equal to negative of A plus B over AB. So C is equal to negative AB over A plus B. Now note that this is crucial because C itself is an integer. Suppose the GCD of AB is equal to 1, meaning that A and B do not have any common factors other than 1. So there exists integer xy such that ax plus by equals to 1, and therefore the square of the left hand side, that is equal to a squared x squared plus 2 of ab xy plus b squared y squared equals to 1. In order to get a squared x squared and b squared y squared, this will mean that a plus b of ax squared plus by squared. So after we expand this, we will have a squared x squared and b squared y squared. But we will have extra ab y squared and ba x squared. And this is a term that we do not want, so we minus ab x squared and we minus ab y squared. And we want to have 2ab xy. Well, the 2ab xy, so minus, so that become plus 2 of xy. And we'll see from here that this is exactly equal to 1. So after all this manipulation, then we see that if the GCD of AB equals to 1, then AX plus BY equals to 1. Now, A plus B of one integer minus AB of another integer equals to 1. What does it mean? It means that A plus B, AB, must be also equals to 1. So what we have here is, if the GCD of A and B equals to 1, then this one is of the simplest form. And if this one is of the simplest form with GCD equals to 1, then C cannot be an integer. So it means that A and B is not of GCD equals to 1. Now, let's say A and B is of GCD D, and D is not equal to B. Then we have similar argument that saying that C is not an integer. So to make C an integer, there's only one possible case. That is, A must be a multiple of B. Right? So let me erase this. So we will say that A is equal to MB. We will let A equals to MB. So this will equal to MB plus B. MB over M plus 1. Now, let's say 47 squared is possible. What does it mean? It will mean that A plus B plus C equals to 47. Now remember that A is equal to MB. So this is MB plus B plus C. C is equal to a negative MB over M plus 1 equals to 47. So factorize the B, M plus 1 square minus M over M plus 1 equals to 47. And therefore B is equal to 47 times M plus 1 over, this will give me M squared plus M plus 1. Now note that M plus 1, and this is M plus 1 plus 1. So what does it mean? Note that M plus 1 and M squared plus M plus 1 is of GCD 1. So they do not have any common factor except than 1. So meaning that in this case, 47 must be divisible by m squared plus m plus 1. Note that when m equals to 6, m squared plus m plus 1, that is 43. M equals to 7 is m squared plus m plus 1, that is equals to 7 times 8, 56, 57. Now, 47 is in between 43 and 56, and therefore it shows that 47 is not divisible by m squared plus m plus 1, and therefore b cannot be an integer. It means that when a plus b plus c equals to 47, there's no integer solution for a, b, and c. And now we confirm that b, 2025, is the only solution. And with this, we can just see that what are the possible values for a squared plus b squared plus c squared. That is, it must be a n squared, where n can be written as a multiple of m squared plus m plus 1 for some m. Example, 7, 13, 43, and so on and so forth. And for now, let's look at other people's solution. If you enjoyed this video, please like, comment, and subscribe. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.